On August 17, 1969, Hurricane Camille slammed into the Mississippi Gulf Coast with winds estimated near 200 miles per hour. It was one of the most powerful storms ever to hit the continental United States. Entire towns along the coast were wiped off the map. Roads vanished under debris. Thousands of homes were reduced to slabs of concrete. But buried inside the catastrophic damage reports was a detail that most people overlooked. The hurricane destroyed more than 50,000 acres of a particular kind of tree orchard stretching across southern Mississippi. These were not pine trees. They were not pecan groves. They were tongue trees, and the oil pressed from their seeds had been, for over 2,000 years, considered the single greatest natural wood preservative the world has ever known. Within a few years of Camille, the American tung oil industry was dead. Production ceased entirely by 1973, and with it disappeared a body of practical knowledge that had protected wooden ships, buildings, tools and weapons across multiple civilizations and multiple centuries. Welcome back to Historia Prime. Today, we are going to trace the complete story of tung oil, from its origins in ancient China to its rise as a strategic American war material, to its collapse under a combination of economics, weather, and industrial competition. More importantly, you are going to learn exactly how to use it yourself, because the chemistry never stopped working. The trees are still growing, and this oil is still available today to anyone willing to invest a little patience. Part 1. The oldest wood finish on Earth. The story begins roughly 2,500 years ago in southern China. References to the use of tung oil appear in writings attributed to the era of Confucius, around 400 to 500 BC. The Chinese word tung means heart, a reference to the distinctive heart-shaped leaves of the tung tree. For millennia, Chinese craftsmen used this oil for everything: waterproofing boats, sealing wooden structures, finishing furniture, and even coating the traditional oil paper umbrellas that were later carried across the Silk Road to the west. But the most dramatic demonstration of tung oil's power came during the Song dynasty, from 960 to 1279 AD. Chinese shipbuilders during this period were constructing massive ocean-going vessels known as junks. These ships had to survive the violent, unpredictable waters of the South China Sea and the Indian Ocean, reaching as far as the coast of East Africa. Salt water is one of the most destructive natural forces when it comes to wood. It rots, it warps, it destroys. Yet these ships endured years of constant immersion. When the Venetian explorer Marco Polo traveled to China in the 13th century, he documented how this was possible. In his famous account, he described how the Chinese took lime, chopped hemp, and a certain wood oil, kneading them together into a mixture that held as strong as any glue. They coated the entire hulls of their fleets with it. What Marco Polo was witnessing was the practical application of a chemistry that would not be fully understood for another 700 years. Tung oil does not simply sit on top of wood the way modern paints do. It soaks deep into the cellular structure of the wood itself, and then it does something remarkable. Part 2. The science behind the magic. Most modern finishes, your standard hardware store polyurethane or varnish, dry through evaporation. They contain volatile solvents. As those solvents evaporate, a hard plastic-like film is left sitting on top of the wood surface. The problem is fundamental. Because this film sits on top, it cannot move with the wood. When the wood naturally expands and contracts with temperature and humidity changes, that rigid film eventually cracks. Once it cracks, moisture gets trapped underneath, and the wood begins to rot from the inside out. Tung oil works through an entirely different mechanism. It is classified as a drying oil, but the word drying is misleading. It does not dry through evaporation. It hardens through a chemical reaction called oxidative polymerization. Here is what that means in plain language. Tung oil contains approximately 80% of a unique fatty acid called alpha-eleostearic acid. This fatty acid has 3 conjugated double bonds in its molecular chain. When those bonds are exposed to the oxygen in ordinary air, they trigger a chain reaction. The individual oil molecules begin to cross-link with one another, building a dense, 3-dimensional network. Think of it like a microscopic chain-link fence being constructed inside the actual pores of the wood. The liquid oil transforms into a solid, transparent, flexible polymer that is locked within the wood itself. It creates a shield that repels water while still allowing the wood to breathe. Because it is flexible, it expands and contracts in harmony with the wood, meaning it will never chip, flake, or peel the way a surface coating does. It is also highly resistant to common chemicals, including acids, alkalis, and alcohol. Consider what this means practically. A completely natural, non-toxic oil that you can apply to a tool handle, a cabin wall, a cutting board, or a wooden boat, and it becomes functionally waterproof from the inside out. No plastic films, no synthetic chemicals, just an ancient molecular reaction between plant oil and oxygen. But if this oil is so effective, why is it not the dominant product in every hardware store? That question leads us into one of the most fascinating economic stories in American agricultural history. Part 3. The Rise of the American Tung Belt. In 1905, David Fairchild, a senior agricultural explorer for the United States Department of Agriculture, brought tung tree seeds from Hankow, China, to America. The US government recognized that depending entirely on foreign imports for a critical waterproofing material was a strategic vulnerability. So, in 1912, the Bureau of Plant Industry began actively encouraging American farmers to plant tung orchards, even distributing free seedlings. The timing was perfect. Across the Gulf Coast states, farmers were looking for a new cash crop after decades of heavy pine logging had depleted the timber. The subtropical climate from the Florida Panhandle through Georgia, Alabama, Mississippi, Louisiana, and into Texas turned out to be ideal for tung trees. By the late 1920s, Florida had its first mechanized tung oil pressing mill, and the industry was booming. By the late 1930s, the American tung belt had grown to enormous proportions. Mississippi alone had roughly 80,000 acres planted in tung trees, and the state was home to more than half of the 7.5 million tung trees growing in the United States. It became a cultural phenomenon. Towns held tung blossom festivals. Communities crowned tung queens. The tung industry was woven into the economic fabric of the Deep South. Then came World War II, and the stakes became existential. Just before the outbreak of war, the United States government officially declared tung oil a strategic defense material. Why? Because military equipment needed absolute protection against corrosion. Every drop of American tung oil was reserved for the war effort. It was used to coat ammunition to prevent deterioration in humid tropical theaters, and it was a key ingredient in the paints protecting naval vessels from the relentless assault of salt water. The Chinese were discovering even more versatile uses. During the war, with petroleum in desperately short supply, Chinese engineers found ways to process tung oil's hydrocarbon chains and use them as motor fuel. The oil that had waterproofed ships for millennia was now powering military vehicles. At that moment in history, tung oil was universally recognized as the premier protective coating available. But the forces that would destroy the American tung industry were already in motion. Part 4. Why tung oil lost the market. There is a popular narrative that tung oil was deliberately suppressed or banned by the chemical industry. The real story is more nuanced and, honestly, more instructive. Tung oil was not killed by a conspiracy. It was killed by a combination of economics, weather, and the basic structure of modern capitalism. First, the economics. In the 1920s, chemists at General Electric developed the first practical oil-modified alkyd resins. These were synthetic polyesters that could mimic some properties of natural drying oils, and they could be manufactured at industrial scale in a factory. By the 1930s, alkyd-based paints were entering the market aggressively. They had genuine advantages that are worth acknowledging honestly. They dried faster, which mattered enormously for professional contractors billing by the hour. They were easier to apply, they required less technique, and they could be produced year-round without depending on a seasonal harvest. But they also had a structural advantage that had nothing to do with performance. Alkyd coatings sit on the wood surface like a plastic membrane. They crack under UV exposure. They peel when moisture gets underneath. And when they fail, you have to buy another can and start over. This creates a recurring revenue cycle. You cannot patent a seed that grows on a tree. You cannot build a multi-billion-dollar industry on a product that, once properly applied, might not need replacing for a decade. Second, there was the tax burden. The Revenue Act of 1934 imposed processing taxes on imported foreign oils, including Tung oil. This was not specifically aimed at Tung oil. It was a broader protectionist measure designed to benefit domestic producers of animal fats and cheaper oils like cottonseed and lard. But the effect was to make imported Tung oil significantly more expensive, right at the moment when cheaper synthetic alternatives were flooding the market. Third, and perhaps most decisive, was the weather. The Tung tree is extremely sensitive to late spring frosts. Between the 1930s and 1960s, repeated freeze events damaged or destroyed crops across the Tung belt. And then came the final blow. On the night of August 17, 1969, Hurricane Camille made landfall. The storm destroyed over 50,000 acres of Tung orchards across Mississippi, Louisiana, and surrounding areas. The Mississippi Encyclopedia records that the industry never recovered. By 1973, Tung oil production in the United States had ceased completely. Facing broken orchards, the rise of cheap synthetics, and years of weather losses, the farmers took disaster compensation and simply never replanted. The American Tung industry was gone. Now, here is the part that matters for you today. None of this changed the chemistry. The oil still polymerizes exactly the same way it did when Chinese shipbuilders were waterproofing junks 1,000 years ago. What changed was the market structure, not the science. Part 5. The hardware store confusion. If you walk into a big box hardware store today, you might see a product labeled Tung Oil Finish. You might think the story ends here, that it has been available all along. Look closer. Most products marketed as Tung Oil Finish are not pure Tung oil. They are wiping varnishes, typically containing petroleum distillates, mineral spirits, synthetic alkyd resins, and metallic chemical dryers. Some contain as little as a few % actual Tung oil. Some contain none at all. The manufacturers use the name because Tung oil carries a reputation for quality among experienced woodworkers. But the product inside the can behaves nothing like the real thing. Here is how to tell the difference. If the ingredient list mentions mineral spirits, naphtha, or alkyd resins, it is not pure Tung oil. Real, 100% pure Tung oil will have one ingredient: Tung oil. No additives, no chemical dryers, no petroleum solvents. There is also a persistent myth worth addressing. Some people hear that Tung oil comes from a nut and worry about triggering tree nut allergies. This concern, while understandable, is based on a misclassification. The Tung tree is not botanically related to almonds, walnuts, or pecans. It belongs to the spurge family, Euphorbiaceae. What is commonly called a Tung nut is actually the seed inside a fruit. Research published in the British Medical Journal found that in test groups with known tree nut allergies, refined nut oils did not trigger allergic reactions. That said, Tung oil can cause contact dermatitis in some individuals, so skin sensitivity is possible. If you have known sensitivities, test a small area first, and once fully cured, tung oil is widely used on food contact surfaces like cutting boards and butcher blocks. Part 6. Your practical guide to waterproofing with tung oil. Everything we have discussed, the history, the chemistry, the economics, all of it leads to this moment. Here is exactly how you use pure tung oil to create a finish that will genuinely outlast anything you can buy in a spray can. Step 1. Source the real material. You need 100% pure, unpolymerized tung oil. No additives, no chemical dryers, no petroleum solvents. This is available from specialty woodworking suppliers and online retailers. A quart typically costs between $15 and $30, depending on the brand and quantity. That single quart can treat a significant amount of surface area. Step 2. Prepare the wood. Sand the surface to at least 150 grit, ideally 220 grit for fine furniture. Remove all dust with a tack cloth or damp rag. The wood must be bare, clean and dry. Step 3. Thin the first coats. Pure tung oil is thick, almost like honey. If you apply it full strength to raw wood, it will sit on the surface rather than penetrating deeply. For the first 2 to 3 coats, create a 50-50 mixture of pure tung oil and a natural solvent like 100% pure citrus solvent, also known as D-limonene. This thinner breaks down the viscosity and drives the oil deep into the wood grain, then evaporates cleanly, leaving only the pure oil behind to polymerize. Step 4. Apply using the wet-on-wet saturation method. Using a lint-free cotton cloth or natural bristle brush, apply the thinned mixture liberally to the bare wood. Your goal is not to paint the surface. Your goal is to saturate the wood. As it drinks the oil, dry spots will appear. Keep feeding those spots. Keep the surface visibly wet for about 40 to 60 minutes. You are filling the cellular structure of the wood with liquid armor. Step 5. The critical wipe down. This is where most people make their only mistake. After the wood stops absorbing oil, take a clean, dry rag and wipe off every drop of excess oil remaining on the surface. This step is non-negotiable. Tung oil reacts with oxygen to harden. If you leave puddles of oil sitting on top, they will partially polymerize into a cloudy, sticky, wrinkled mess that you will have to sand off. Wipe the surface completely dry. The wood should look rich and enhanced, but not wet or glossy. Step 6. Cure and recoat. Allow the piece to rest in a warm, dry space with good airflow for 24 to 48 hours. This gives the oil time to begin curing inside the wood. You do not need to sand between coats, but a very light buffing with ultrafine steel wool will give you an incredibly smooth result. For maximum protection, apply a total of 3 to 5 coats. For the final coat, you can use the tung oil at full strength without the citrus solvent. Step 7. The patience of the ancients. After your final coat is applied and wiped dry, you must wait. The complete oxidative polymerization process, the building of that microscopic chain-link fence inside the wood, takes 15 to 30 days, depending on your climate and temperature. During this curing period, the wood is vulnerable, but once those 30 days are up, the transformation is permanent. You will have a piece of wood that sheds water, resists chemicals, and will never peel. And here is the honest maintenance reality. Tung oil does not literally last forever without any attention. After 5 to 10 years of heavy outdoor exposure, including direct UV sunlight, the finish may begin to look dull. But unlike synthetic coatings, you do not have to spend days sanding and scraping and stripping down to bare wood. You simply wipe on one thin maintenance coat of oil. It bonds instantly with the existing polymer network, and your protection is completely restored. That is the true advantage. Not that it never needs maintenance, but that maintenance is effortless, compared to any alternative. Critical safety warning. I must be very clear about this because it could save your property or your life. The chemical reaction of Tung oil polymerizing is exothermic. It generates its own heat. If you take the cotton rags you use to apply or wipe up the oil, ball them up and throw them in a trash can, the heat has nowhere to escape. The rags can and will spontaneously combust. This is not theoretical. It is a well-documented cause of workshop and house fires. Always hang your oil-soaked rags flat outside in open air to dry completely, or submerge them fully in a sealed metal container filled with water before disposing of them. Never leave wadded-up oil rags in an enclosed space. Ever. What Tung oil will not do. In the interest of honesty, and because your trust matters more to us than hype, here are the limitations. Tung oil is not ideal for surfaces that take heavy mechanical abrasion, like high-traffic commercial floors. For those applications, a hardened polyurethane topcoat is genuinely the better choice. Tung oil also requires more time and technique than brushing on a can of quick-dry varnish. If you need a fast turnaround, synthetic coatings will always be faster to apply. And Tung oil alone will not protect wood indefinitely from intense, sustained UV exposure without periodic maintenance. What Tung oil does better than any synthetic is protect wood from moisture penetration from the inside without trapping water underneath a film. For outdoor furniture, decks, fences, tool handles, cutting boards, musical instruments, boats, log cabin walls, and anything where you want genuine long-term water resistance with a natural, food-safe finish, nothing on the market matches what this 2,500-year-old technology delivers. The story of Tung oil is not really a story about corporate villains or government conspiracies. It is a story about how economic incentives shape what products end up on store shelves, and how that is not always the same as what products work best. Alkyd resins won the market because they were faster, cheaper to produce, and generated repeat business. Tung oil lost the market because it was too effective, too durable, and too simple to generate a recurring revenue stream. You cannot build an empire selling a product people buy once a decade. On the night Hurricane Camille destroyed the last great American Tung orchards, an entire industry and a living tradition of applied knowledge was swept away. But the chemistry survived. The trees still grow across China, South America, and parts of Africa. The oil is still pressed from their seeds, and it still polymerizes into the same transparent, flexible, waterproof armor that protected Chinese war fleets 1,000 years ago. Now you know the full story. Now you have the method. The only thing standing between you and a finish that will outlast anything in the paint aisle is about 30 days of patience. If this video taught you something you did not know, subscribe and ring the bell so you do not miss the next one. Share it with anyone you know who is tired of repainting their deck every 2 years. And as always, stay curious, stay prepared. I will see you in the next episode of Historia Prime.